energy energy in SHM. Energy in SHM. Okay, that is the second point. Okay, so when we what happens? Suppose when you have a spring, suppose this is, and there is a block, okay, of mass m. Okay, so what happens when you what you do? Suppose if I'm not giving you a block, just the spring, okay, when you apply the force on the spring, when you pull it, okay, when you pull it in your direction, okay, in the right direction, there is some point at which point you feel like you cannot pull it anymore, right?
Yeah.
Right, Kevin? So what is
Yeah.
that? That is the maximum displacement possible. Can we say it? Suppose after extending it, if I'm saying spring is like this, spring is extended like this, and that is the extreme point. After that, you cannot extend it.
Okay.
So will it be said like that is the maximum possible distance of x? Right? Maximum possible displacement. So that could
Yeah.
be called as amplitude, right? Amplitude, right?
Yeah.
Okay. Okay. So that is the maximum possible distance. Suppose you have, okay, you cannot pull it. Okay. So what happens when the spring is pulled to a x distance? Okay. Not to the, like, till any x distance. If the spring is pulled till any x distance, what happens in the string? A potential energy. Okay. Potential energy in the spring is stored. Okay. What kind of energy? There are two kind of energies. You remember in the last chapter we have studied the potential energy and the kinetic energy, right? Right,
Yeah.
Kevin? So what is potential energy? Potential energy is stored in the body or in the system. And kinetic energy, when something is moving. Kinetic energy is defined only when something is at v. It is not still. Okay? It has some velocity, right?
Yeah. Okay.
Right? Okay? So when you start pulling the spring, so it was going with a speed v till this direction, right?
Yeah.
Right? So it was having which kind of energy? Kinetic energy. Okay? But at the extreme point, when the velocity becomes zero, now you cannot pull it anymore. Then what happens?
It's all the potential
All the
energy.
kinetic energy is converted into potential energy. Right?
Yeah.
Right? So potential energy is stored into the body. Now when you leave it, this potential energy is again converted into the kinetic energy. So that's why with a v speed, this extreme position comes back to contract the spring, right? Right?
Yeah.
Right? So the stored potential energy term can be written as P in a spring. It can be written as half k x square. Okay? Okay? That is the
Yeah.
formula.
Okay.
If is maximum, if x is what? Maximum. Maximum means the maximum displacement possible. Then x will be equal to what? A, right? Then
Yeah.
P
Okay.
can be written as half of k a square. Fine? Okay? Getting my point?
Yeah. Okay.
Okay? Similarly, the formula, this is A, potential energy, and when I leave the spring, so the kinetic energy can be written as half mv square. Okay, half m v square. Okay, v is what? V is the speed of the point at which speed it is moving. Okay.
Okay.
Okay. So kinetic energy is independent of the, here can we see independent of the x. Okay. So that is kinetic energy. Kinetic energy of the spring. Okay. So what will be the total energy? Total energy is equal to T, that is P plus Ke, right?
Yeah. Okay.
Okay. So that is half K x square plus half mv square, right? That is called E or T. You can represent with any one. This is
Yeah.
what
Okay.
this is what total energy, right?
Okay.
Okay.
Yeah.
Getting my point?
Yeah. I got it.
So if I say that if you suppose that what happens, there are so many points. Suppose you are at a mean position. Okay. Now I will tell you the modes of these energies when this is okay. Suppose you are at mean position. Okay. What is it? V is 0 here, right?
Yeah.
Right, Kevin? V is 0 and x is 0, right?
Yeah. Wait, isn't oh yeah. Okay.
At
X is
mean
0.
position, x is equilibrium, right?
Yeah.
So there is no velocity v, right? And there is no x. So what can I write? What will be the velocity? What will be
So it's 0.
0, right? So suppose this is a mean position. I should make the diagram big. So at me, I will name it mean position. Mean position or equilibrium position. Okay. So v is 0 here, x is 0 here. So what is the energy?
That's only half mv squared.
Half mv square. Why? When v is 0,
Half kx squared.
so x is 0 as well. So what is the total energy? Kevin, just look at the
So
formula here and then you
it'll
put the
be
value.
0.
What? E is 0,
It'll be
right?
0. Yeah.
E is 0. Now what happens? When the spring, when I what I do is on the spring, I apply some force. Okay? So if I apply some force, there will be some acceleration, right?
Yeah.
So that acceleration will give some velocity to the spring, right?
Yeah.
So it will start going to the extreme position, right? This way.
Yeah.
So it will have some velocity.
Yeah.
It will have some velocity, right? So
Yeah.
at it, when it will have some velocity, it will have kinetic energy.
Yeah.
Okay. So if it is kinetic energy at the extreme point, this is extreme point. Extreme right point. I called extreme right point. So with that velocity, the spring comes to the extreme point, and here velocity becomes 0, right? Like you started moving and then you stopped at velocity v. Why you have stopped at velocity v? Because the all the spring pulled is completely spring is completely pulled, so its velocity becomes 0 at this point, right?
Yeah.
If it is 0 at this point, what will be x at this point? Extreme right point. Given
That'll be like an x max.
x max, so that is plus a, right?
Yeah.
Plus a, why I'm writing? Because it in the positive
The amplitude.
right direction. Okay. After that, what happens? What will be the e here? Tell me the value of a. E.
That's half kx squared.
So x will be a, right?
X is a.
So half k square, is it right? Half k square, right?
Yeah.
Half k square. Okay. Okay. After that, if I then this again spring will come back, right? This will come back to the mean position, right?
Yeah.
So again it will, when it will again come back. So what, it will have some velocity, or the velocity will become 0?
It'll have velocity.
It will have velocity. Yes, great. Okay, that is 3. Now 3 I'm writing. What is 3? Velocity will be maximum here. Okay. So that's why velocity, if velocity is maximum, so that's why it can go into the left side. Okay. When it is coming from the right side, it will have velocity, and x will be what? 0.
0.
So 3 at this point 3, this can be written as, wait, E1, E1, E2, and E3 will be what?
That will be a half mv max squared.
Half mv max square. Okay. Okay. Now moving to the, again it will, with that v max, it will come to the extreme left point. Extreme left point. Okay. With that extreme left point, again v max will be 0. V will be 0. And x is equal to what? Minus a. Same. Just minus a. Why? Because it is in the left direction. Okay, right? Right?
Yeah, okay.
So what will be the E4? E3, E4. E1, E2, E1, E2, E3, E4. Yes, E4 will be what? Half
We have
k square.
um,
Just a is become minus, right? X become a minus. So square will be same, right?
yeah.
And v is 0. So again, same potential energy will be stored, right? Now it will go back. It will go back again. Okay, wait. It will go back again to this mean position. Okay? It will go back to again same position. So what will be? V is equal to 0 and x is equal to 0. Okay? V will be 0. Now at this point, since one cycle is repeating, one cycle is completed. Okay? So V will be 0 and x will be 0. Okay? Like it can do some oscillation in the real. If I have given the energy of just one cycle, then the V will be 0 and x will be 0. If I have given just one cycle, then the just one cycle will be completed. If I have given more energy than one cycle, then it will still not be 0 here. It will still go in this side, and it will be stopped until complete so many cycles, right? Right, Kevin? But
Yeah.
supposing I have given energy just of one cycle only. Okay. So did you get my point?
Yeah.
What will be the energy, complete energy? How will you calculate complete energy? So there will be the
kx squared plus half mv.
exactly. So there will be so many questions based on this combination. So you always remember that. Okay.
Okay.
Okay. Got it?
Yeah, I got it.
Okay. One more thing. Okay. From here we'll figure out the formula of velocity. Velocity is what? Velocity is v. The formula of v is equal to a omega square minus x square. Okay, this is the formula of velocity.
Wait, that's the angular
No.
velocity?
Oh, not this. V is equal to omega a square minus x square. That is the formula of velocity. Okay, that is the velocity of the same velocity v. Okay. Yes, Kevin, you're saying
Wait,
something?
that's the angular velocity?
No, not yeah, omega is here. Omega is not angular velocity. Here omega is what? Omega, that omega, I think the free omega is equal to 2 pi f. Do you remember? 2 pi f. That
Yeah.
is the formula. Here omega is frequency, angular frequency. What is the angular frequency? The revolution it is making place to and fro motion. Okay.
Yeah, I know.
The revolutions, like not the circular revolutions. Here the revolution of to and fro motion. These are revolutions. Okay. So omega is angular frequency of those motions. Okay. Which kind of motion? To and fro. Okay. Not circular. To and fro.
Okay.
Okay. So that is the angular frequency.
Okay, yeah,
Okay,
like that.
so omega is that is the formula of velocity. Okay, velocity v is equal to omega. Now omega do you know what is the omega value of omega? Omega is square root k by m,
Two
right?
pi. Wasn't it 2 pi f?
That is the square root. Yes, omega is square root k by m, a square minus x square square root. Okay, so if we write v square can be written as k by m, a square minus x square. Can I write that?
Yeah.
Okay, so this is the formula of v square. Okay, so
Okay.
if you want to, oh, okay, so similarly if you take what you take, if you take a common, k by m, if you take common a square, so it will be 1 minus x square by a square. Can I write that? Can I
So
write
that's
that?
if you take. Yeah, you can write
So
like that.
a will be outside a square, right?
Yeah.
Okay, what is, so that is called v square. Now v max, v max is what? Just see here, v
It's like
max,
the maximum you can pull.
this is the v maximum, right?
Yeah.
Okay, so v maximum is k a square over m, that is the v max. Okay, so can I write v max square 1 minus x square over a square, right? Can I write that?
Um, yeah, yeah, you can write like that.
Okay, or you should say v max is equal to a omega. Just always remember that a omega. Okay, okay, so
Okay.
from here v max square will be what? A square, and omega is k square by m square, k by m, right? So from here we are getting that. So can I write v is equal to plus minus v max 1 minus x square over a square? Can I write that?
Yeah.
Yes, that is the definition you should remember. That is the for the velocity. Velocity in terms of x and a. Okay, these are the formulas that you need to remember according to the question necessity. Okay,